A pleasant day, Ma'am and Sir. We are here to present to you our research proposal. To formally start, let me first virtually introduce the researchers of this study. Starting with Ms. Joanne Duliente, Mr. Daryl Cabanting, Mr. Rayward Sagario, Mr. John Lloyd Mingala, and yours truly, Mr. Ryan J. Panjo. This video presentation will include the discussion of the title, the introduction, as well as the objectives and the materials and methods that we are going to use. Our research proposal is entitled Round and Crush Coarse Aggregates in Concrete Mixture, a Comparative Study. Nowadays, infrastructures around the world have been progressing and widely in demand to accommodate the needs of the increasing world population. As the number of buildings under construction continues to increase, the use of the natural resources needed for construction will also increase. Aggregates are the basic raw materials which are essential for all construction activities. It is classified in two types, which are fine and coarse aggregates. Fine aggregates are those that pass through a number 4 sieve. Materials that are retained are coarse aggregates. Coarse aggregate is one of the main components to provide and responsible for the adequate strength of concrete. Their primary use is to strengthen the concrete and offer several benefits in the making. Also, coarse aggregates have different types. Some of them are round and crush. We came up with this research title because according to some beliefs, crush aggregates contribute higher strength compared to round aggregates. But as stated by Hashani et al. 2017, they found out that round aggregates perform better than crush aggregates because the rounded shape, which is considered as a negative characteristic, is compensated by improving the workability and reducing the need of mixing water. Thus, the water-cement ratio, these essential parameters lead to gaining strengths in concrete. Another thing using round coarse aggregate will also cut the project cost since it is cheaper than crush coarse aggregates. Furthermore, according to Kumar et al. 2018, emphasizes that a laboratory test result in compressive strength due to the RCA's higher density and lower absorption than crush aggregates, it will give better compressive strength in the concrete mixture. However, the water-cement ratio in the concrete is crucial since it can affect its workability and compressive strength. On the other hand, as per Ejogu et al. 2018, the strength of the concrete increased as its water-cement ratio is lesser, and it needed a 0.5 to 0.7 ratio to meet the necessary slump of 25 to 100 mm using the slump test. Meanwhile, a 0.8 to 0.9 water-cement ratio will lead to a shear and collapse slump. This only shows that increasing the water-cement ratio by adding water to the concrete mixture, aiming to match the slump or workability of the other concrete sample, will end up decreasing its compressive strength. Thus, this research aims to compare the compressive and tensile strength and workability of Class A concrete having crush coarse aggregates and round coarse aggregates, thereof the size of aggregates, the source of materials, the cement-sand aggregates ratio, and water-cement ratio will be the same. Ensuring the parameters that difference in some variables will not affect the ultimate objective of this study. Therefore, the researchers will conduct a comparative study between concrete with crush coarse aggregates and concrete with round coarse aggregates, considering its workability, compressive strength, and tensile strength. Specifically, it sought to answer the following. First, to make a comparison between concrete with crush coarse aggregates and concrete with round coarse aggregates, considering the following criteria: workability, compressive strength, and tensile strength. Second, to determine if there is a significant difference between concrete with crush coarse aggregates and concrete with round coarse aggregates, considering the following criteria: workability, compressive strength, and tensile strength. To further know about this research study, here are the operational definitions. Concrete with crush coarse aggregates. It refers to a Class A concrete mixture having a ratio of 1:2:4 cement fine aggregates crush coarse aggregates components. Concrete with round coarse aggregates. It refers to a Class A concrete mixture having a ratio of 1:2:4 cement fine aggregates round coarse aggregates components. Workability. It refers to the measure of a slump test, freshly mixed concrete with crushed coarse aggregates and concrete with round coarse aggregates. Tensile strength. It refers to the average recorded tensile strengths of the group or set of concrete cylinder specimens after subjecting to laboratory testing. Compressive strength. It refers to the average recorded compressive strengths of the group or set of concrete cylinder specimens after subjecting to laboratory testing. Now let's go to the materials and methods. The raw materials that we will use in this study are the following. Cement. Portland cement, 40 kg each bag. The cement that will be used in this study was obtained from Republic Cement and Building Materials Incorporated. Fine aggregates. The researchers will use sharp river dredge sand passing through the number 4 sieve obtained in a quarry located at Bacolod, City of Ilagan, Isabela. Round coarse aggregates. The researchers will also use round coarse aggregates passing through 3/4-inch sieve and retained through a number 4 sieve obtained in a quarry located at Bacolod, City of Ilagan, Isabela. Crushed coarse aggregates. The researchers will use crushed coarse aggregates passing through 3/4-inch sieve and retained through a number 4 sieve obtained in a quarry located at Bacolod, City of Ilagan, Isabela. Water. The potable water that will be used in this study is obtained from a tap from Isabela State University, Ilagan campus. The water was colorless, odorless, tasteless, and free from organic elements.
Thank you, Mr. Ryan J. Bancho, for presenting the introduction and objectives of the study. I am Daryl D. Gabanting, and now let's proceed to the methods of the study.
To determine the objectives of the study, the researchers will follow and conduct standard guides in conducting the following. First, the slump test, followed by making, as well as curing and testing of concrete cylinder and concrete beam specimens. The researchers will gather all the raw materials, apparatus, as well as the machines and equipment that are needed in this study. After the selection of raw and manufactured materials, the researchers will proceed to sampling and testing. Fine aggregates, round and crushed coarse aggregates, water, and cement are the raw materials needed in this study. In selection of raw materials, the researchers will need the following: sieve number 4 and sieve number 10 for mechanical sieving of aggregates. Second is the stone crusher, in case for producing crushed coarse aggregates from bigger stones. And finally, the weighing scale. While for conducting the slump test and for making, curing, and testing of concrete cylinder and rectangular beam, the researchers will need the following: slump cone set, tamping rod, rubber mallet, scoop, shovel, cylindrical molder, rectangular beam molder, vibrator, curing pond, and universal testing machine. The experiment will begin by making two different mixtures of fresh concrete with round coarse aggregates and crushed coarse aggregates for the slump test to determine and compare the workability of each mixture. Then, the researchers will mold two different batches of specimens with round coarse aggregates and crushed coarse aggregates for concrete cylindrical molder and concrete rectangular beam molder for curing and testing of the sample specimens. Lastly, mixture will be tested at different curing days, 7 days, 14 days, and 28 days respectively. The compressive and flexural strength values of the specimen will determine using the universal testing machine. The resulted data derived from universal testing machine will be compared after the last testing is done on specimens. The researchers will now use t-test in this study to determine if there is a significant difference between concrete with crushed coarse aggregates and concrete with round coarse aggregates in terms of workability, compressive strength, and tensile strength.
Thank you, panelists, for listening to our virtual presentation entitled Round and Crushed Coarse Aggregates in Concrete Mixture, a Comparative Study. And the room is now open for any suggestions and recommendations. Once again, thank you.